Yes. This is Dr. Senthil Kumar, Associate Professor, Department of EEE, SNS College of Technology. Now we are sailing in this video series a design of sequential circuit. Typically a design of counters, modern counters, up-down counters, and case study of the elevations and dice simulators. Now let me discuss about the design of mod n counter. Mod n in particular up down counters. Mod n up down counters. We know that the applications of the counters, we know that the application of counters, we know that the application of counter is in all digital electronic devices. The very good example is our cell phone, which I have discussed earlier, right? Now let me see the example of a design of a modular and up down counter. Modular and up down counter. Yes. As okay, for a design of a synchronous up down counter, we have to apply a special input which may be up bar down bar, up or down bar, which when up bar down bar which counts 1, which means the counting is in upward direction, which means 1, the counting is in upward direction. If it is 0, which means that the counting is in downward directions, right? A special input terminal is required whether the counting device is in up or in down. The other remaining parameters for a design of a synchronous counter remains same, except this, and a special input control terminal is required. Whereas here we are named it as up bar down. And again stating that up bar down is 1, the counting is in ascending order. If it is 0, then it is in descending order. Now, let me design a 3-bit up-down synchronous binary counter. For this video, the question asked or the question given is you have to develop the state table and the excitation table for a 3-bit up-down counter. The state diagram for a 3-bit, you mean if it is a 3-bit, the number of possible combination is 8, from 0, 0, 0 to 1, 1, 1. The number of possible combination is 0 to 7. You mean total 8 possible states. And 8 possible states may be drawn in the form of a circle, and when it is in increment order, then it is up counter. When it is in decrement order, then it is a down counter. See the excitation table which is shown here. Yes, the excitation table. And the clock pulse is from 0 to 7. The clock pulse is from 0 to 7, it is given. And for up counter, see here, when the first input is 0, 0, 0, the second next state will be 0, 0, 1. And when the present state is 0, 0, 1, the next state will be 0, 1, 0. It goes on for an up counter. See here, the arrow mark is given for an up counter from 000 to 001, and 010 it goes on. Whereas for your down counter, the table has to be reversed. The first value will be 000 as usual. Whereas see the arrow mark in the down, it is coming in the bottom line. Therefore, from 000, the next state will be 111. The next state will be 111, 111. And when 111 is the present state, the next state will be 110. Therefore, it is descending order. The arrow mark in the table clearly mentioned that the right hand side is the descending and the left hand side of the table is in ascending order. Thus, the state diagram and the excitation table has been drawn, and with the help of a T flip-flop, let me choose, since the flip-flop is not given, let me choose a T flip-flop, and if we chosen the T flip-flop, then filling the excitation table and the extraction of the excitation table, you mean the minimized expression with the help of K map will be as Yes, this is the excitation. After the excitation table, the expressed K map will be, since there are three flip flops, the TQ naught is 1, and TQ1, you mean the second flip flop. TQ1 is Q naught into up. The up is nothing but the special terminal. When up is 1, then it is up counter. When up is 0, then it is a down counter. And plus Q naught dash into up dash. This is the input for the second flip flop, second T flip flop. And the third flip flop, TQ2 is equal to Q naught into Q1 into up plus Q naught bar into Q1 bar into up bar. As per the minimized expression from the construction of this excitation table, we can easily draw the expression as. See, the expression is again, it is written TQ0, TQ1 and TQ2. Q0 is for the MSB flip flop and Q2 is the least significant bit, LSB flip flop. Now let me see the logical diagram. It is drawn with the help of this expression. The logic diagram is S. This is the logic diagram. Again, see the three flip flops, three flip flops, and the clock pulse is given in the blue color, which is connected parallelly, therefore it is synchronous. And the up is a special terminal. When it is 1, it is up counter. When it is 0, it is down counter. And the first flip flop is Q1, which is your LSB, and the extreme right is your MSB, most significant bit. It is Q2 and Q1 and Q0. Therefore, this logic diagram represents a 3-bit up-down synchronous binary counter. Hope you understand the derivation and the logic diagram of up-down counter. Thank you for patient listening. Thank you.